people here that will need that. All right, so yesterday we talked about rational expressions, and we talked about rational expressions are actually just what? Fractions, okay? Multiplying and dividing fractions are easy, right? Yes. Why is adding and subtracting fractions harder? You've got to have a least common denominator, okay? So that's what we got to talk about first, is how to find that least common denominator. So if you think about it, let me give you an example here. Let's say I have 1 over 12 plus okay, and I want to find, we're going to find the LCD, the least common denominator. 1 over 12 and 1 over 15. All right, so here's what I want you to do first. I want you to write these numbers in prime factorization, the denominators. Yes, like the factor trees. Like you start with 12. What multiplies to give you 12? 3 and 4. 4 breaks down 2 and 2. So 12 is the same thing as 3 times 2 times 2. Okay? Yep, 3 and 5. So you're writing them with only the prime factors, okay? Bring them down as far as they can go. So I have, prime means it can only be divisible by 1 in itself. Okay. So you keep breaking these numbers down until you can't break them down anymore. Okay. So what is the prime factorization of 15? 3 and 5. Now, I have a reason for doing this. Sarah already said, what did you say you thought, just looking at these, what did you think the least common denominator was? 60. Oh, wait, some of us are saying what? Yes, no, maybe so. Least common denominator is the same thing as the least common what? Multiple. So multiples of 12, 24, 36, 48. We're out of room here. Hold on. Okay. Well, but I didn't want to run into my factor tree here. Okay. And 15 would be 15, 30, and you don't even, oh, you do. Never mind, just kidding. 45, 60. So here is the least common multiple, okay? Oh my goodness, I'm going right, okay? Least common multiple. Okay? So, yes. Okay. All right. So what I'm really doing is I'm showing you something you've done. I hope a teacher has shown you the prime factorization that I'm fixing to show you. And how to find an LCD also, rather than just listing out the multiples the way that we have done here, because that can get kind of messy sometimes, okay? If you can do the prime factorization, then what you can do is you can say, I understand that each denominator has to be completely included in the LCD, yes? In other words, I need to make them be the same where I can multiply this by something and this by something to make them look the same. Okay? So a 3, a 2, and a 2 have to be in that denominator because it's in this one. I can't take anything away from it, right? But when I come over here, well, there's already a 3 in it. I don't need another 3. But I do need the... And this is kind of a little more complicated than what you would normally think about whenever you do these, but it's going to help you understand when we get to the big polynomials, okay? Well, 3 times 2 is? So the LCD is still 60. Okay?
You can do that instead of listing out all of those.
Okay, but we're not, it works the same way, but of course we're not going to be working with just numbers, we're going to be working with polynomials. So what I want you to see is we're taking the multiplied factors, because we're talking about factor chunks, right? We're taking the factors, we wrote this whole first denominator, and then we picked up anything it was missing from the second denominator, okay?
And you multiply the
No repeating numbers. Right. No repeating numbers unless the repeating happens like this in the same fraction. You see what I'm saying? So now I could easily look at this and go, okay, I've got a 3, I got a 2, I got a 2, but I need a 5. And I would do top and bottom by 5. Right? I thought I forgot to hit record. Here I've got a 3 and a 5. I need a 4 or a 2 and a 2. So I would give that to the top and the bottom. That would force the same denominators. Does that make a little bit of sense to you? All right. I'm going to give you. Evan, you're never going to remember this if you don't write it down. You just held up a blank piece of paper. The place where students struggle the most on this is finding LCDs. Okay, finding what that LCD is. So I want to practice with you for just a minute. I want you to think about something. What if I had, and we'll come back to what to do, how to combine them. What if I had this?
Take out the 3s.
All right, remember the key to this. You know how with the numbers there, what we had to do was we had to prime factorization, right? So we're going to factorize this one. Okay, we're going to factor down everything we can. It's a sign. Okay. I didn't finish it yet. I'm going to come back to it. All right, shh, guys. I feel like I'm... All right. So here's what we're going to do. We are going to completely factor everything. Justin. We're going to completely factor everything just like we did when we were doing prime factorization, or just like we did when we were simplifying each one. Because the first step when you do anything with rationals needs to be to factor. So let's get to it. How about this one? Take out a 3. How about this one? Take out a 2. And then this one, -5 and +1. So I'm going to rewrite it so it's nice and neat. X over 3 times x minus 5 plus 2 plus 1 x minus 5. And so what I want you to think about when you look at this is I want you to think about these parentheses and these numbers being the same thing as those numbers when we wrote in prime factorization. They just look a little different, but they're still factors, okay? They're still things being multiplied. So everybody agrees they're factored completely? So let's see if we can form the LCD here. Okay? No, because there, see that addition sign in the middle? So I can't do that just yet. So instead what I'm going to do, no. All right. Looking at this, tell me what you think the LCD is of these two fractions. Yes.
Wow.
All right, look. Look at the pieces that are being multiplied when I look at the bottom. I've got a 3, an x minus 5, an x minus 5, and an x plus 1. Just like before, I didn't have these x plus 1 or x minus 5. Instead, I had, this would work so much better if this thing would listen to me whenever I said go back.
And you don't repeat the x minus 5.
Exactly, because you don't need the repeater. Then it would be a common denominator, not a least common denominator. So if you look, it's just like this, 3. Okay, these are my pieces now instead of just numbers, though. What did you ask? Where'd the what go? Which 2? Hold on, it's thinking about going back to the screen. It's trying. It's thinking about it now. It's the blue circle of death. Okay. That's on the top. I'm not worried about that just yet. Right now, I'm just looking at the denominators. Oh, yes, just wait, just wait, just wait. All right, so
Wait, can you explain why this
I took the first denominator, which is 3. Y'all, I don't know. All right. So, what was the question now?
Why is it? I think I see why, but I think
So you write the first denominator, okay? Because I need to complete it. And then what pieces are missing from this one that I need to add here? X plus 1. Correct, correct. Your end goal is that you need an LCD that can list out terms so that you can give each one what they're missing, okay? So, looking at this, if I need to make this look like this, what does it need? On x plus 1. Top and bottom, right? And what about the second fraction? A 3. You're just giving it what it needs right now, okay?
write this down.
All right, take a second. Shh. All right, look back at this one. We said the LCD was 3225, right? Or, in other words, 60, right? And so we gave everything what it needed. So what is the next step? Once you have the denominators that are exactly the same with any fraction, how do you add them? What do you do? All right, so, well, let me go ahead and do that. So 5 over 60 plus 4 over 60.
Yeah, you add the different problem that we did.
Yes, I am. I went back.
We don't have room to go back. We go.
So the blue is lost.
Nope, I'm going to go back. I'm making a connection.
Oh.
Yeah. All right, shh, guys. Yes. Remember how whenever we were doing polynomial long division and I ran an example alongside and then we did the I'm kind of doing that same kind of process. I did. I said I'm coming back to this. You were talking. I know. All right. When you get to this point with fractions and the denominators are the same, what do you do? Okay, combine the numerators. Whether that's addition or subtraction, yes? No. So this would be 9 over 60, and then you simplify from there, right? So this is what we're going to do. So go back to your other problem. It'll go back in a second. Just give it a minute. Okay. Now it's got to scroll up. All right, so we gave it what it needed, right? The first one needed x plus 1. The second one, and I'm just going to write, if I were not showing you this for the first time, I wouldn't rewrite this over and over, but just so you see, 2 times 3, x plus 1, 3. Just so you see that the denominators are now completely the same. Do you understand that? Yes. Let me get there. All right. At this point, I have common denominators. Are we in agreement with that? Yes. So once I have common denominators, I can combine the numerators. Yes? All right. So here are my numerators. So what I have is, and I'm not doing any type of simplification yet, x times x plus 1 plus 2 times 3, well, I will combine that to 6. X plus 1, and everything's over now my LCD, right? Yes, Miss McGee. No, Miss McGee.
Yes.
You're writing in the sentences. You don't understand this.
We see where we got the LCD, right? Yes. Do we see how we forced the LCD?
Yes.
Okay. I mean by, do you see where we added this green here to make the LCD the same? Okay, and we did it to the top and the bottom. So all I did in yellow was I rewrote the numerators here. Do you see that? Now all I have done is I have written them together, x, x plus 1, 6, x plus 1, and put them over the LCD. Okay? Don't make it, it's not a hard concept, it's just that they're long. Yes. All right. Can I start crossing stuff out? I got that addition there. Remember.
Combine them.
All right, listen. Listen. Here's your cube that you can't start. When I'm adding or subtracting, okay, I've got a plus sign here that is outside of parentheses. If you see a plus or a minus that is not inside parentheses, do not start canceling out because you're in that scenario. Every plus or minus has to be included in parentheses. So this is where this gets more tedious in the multiplication division because I've got to figure out how to get it factored. Before I can get it factored, I need to multiply it out. Yep. X squared plus x plus 6x. I distributed. You could, yeah. Yeah, you could. It's already set up to group, but most of them aren't going to do that, so I wanted to walk you through, but yes. All right, so I have x squared plus 7x plus 6, and a lot of you recognize that here it's already set up to group, but just to show you how to expand and then shrink back down, now I can factor the numerator. It was halfway there, yeah. All right. X plus 1, x plus 6. Combining the numerator. I multiplied the numerator out, simplified it, and then factored it. Now I want you to notice that every plus or minus in here is completely enclosed in a parenthesis. Do you see that? I factored it because the leading coefficient was 1. I just looked for what multiplied to 6 but added to 7, and it was 6 and 1.
So x plus 1. All right.
Yes, now I can cancel. I'm out of room, and I apologize for doing this way.
Wait, how does that x times x right there.
Oh, I have one.
Same thing with the others. Find LCD, force LCD, and before you find the LCD, make sure everything is factored completely.
Can we change the word force?
Yeah, that's kind
Whatever you want.
of
Make it be the LCD. Guys, I'm gonna record again. I think if we run through an example start to finish, it'll be very helpful. All right. I need to make sure everything's factored before I find my LCD. Yes? Correct. All right, so let's factor up top. That's good. How about the bottom of the first fraction? Take out a 2, right? All right, so I have x minus 1. Subtraction's going to kill us up top. We've got to be really careful. How about the bottom here of the second fraction? I wouldn't do it just yet. Just wait.
it's -1.
-1 and -3. Very good. Yes. Yeah. Like, you want me to pause the video? It will in a minute. It will in a minute. All right, let's find the LCD. job.
Let's see, I work.
2 x minus 1, and then in the second fraction I need it to be x minus 3. So give everybody what they need. That's right. So x minus 3 here, Colin says, and that is correct. And here, 2. All right. Here's where you have to be careful, because whenever I combine the numerators here, I got a big fat minus in the middle. All right, and that's going to have to be distributed through. I've got to take account for that. All right, so first fraction, I've got x plus 2, x minus 3, minus, I'm going to put the 2 in front so I can distribute that a little easier. Now, if it didn't have the 2 in front, you'd want to make sure, even still, that you put this in parentheses so that you would know that minus sign distributes through to everything. Okay? All right. Everybody goes over the LCD. Is it time to start crossing out? No. Why? What do you see? I see a subtraction in the middle of the fraction up top, right? So I need to handle that, which means I'm going to have to multiply it out first, and then I can shrink it back down. Yes. Mm-hmm. So x squared and before I simplify that or anything, I'm going to go ahead and distribute this 2 through so that I can just gather all my like terms at the same time. So negative 2 times negative 2x is positive 2x, positive 4x. No, it's me. 4x. And then negative 2 times negative 1. I was looking ahead and there at the same time. All right, everybody's still over the LCD. I hope you're seeing that the concept is the same as when we add fractions. It's just that these fractions are nasty. Yes. So I end up with, come on board. There we go. X squared, I told you make sure you have plenty of room. Negative 3, positive 2, and positive 4. Plus 3x. Minus 4. Now, a lot of times you'll get to this point, and you won't be able to factor any further, and that's okay. There's nothing wrong with that. In our case, though, we're not. Positive 4 and negative 3. I mean negative 1. God. Sorry. Oh, I know, right? I'm sorry. Now I can cancel, right?
Actually, 4 will be top. Or factor it.
Yes, I factored the top. Multiplies the negative 4 and adds to 3. X minus 1 cancels. Tell me what you think. It's not bad.